Hi, I'm Herman, a PhD student at the University of Minnesota studying computer science. I'm presenting on behalf of an interdisciplinary team that is comprised of artists, domain scientists, and computer scientists with a focus on bringing art and design theory and practice into visualization. Printmaking, puzzles, and studio closets focuses around our process for reimagining the user interface for designing 3D, multivariate visualizations. Our main research question is, how do we build a user interface to bridge the gap between creative processes and the inherent technical process associated with creating data visualizations? Our team has been working on this hard problem for a while, and last year we developed the artifact-based rendering technique, also known as ABR. This technique allows artists to use their own clay sculptures, ink washes, and other physical media in combination with data, resulting in more expressive and engaging 3D visualizations. Until now, the last step in creating visualizations required a programmer to connect the data and computer graphics algorithms to the artist-designed building blocks. Today, we're presenting a user interface that allows artists to contribute even in this last step. The approach we've taken is not to hide the complexity of the technical computer graphics aspects of the visualization process, but rather to translate these into an artistic, technical language. Our language of choice for this visualization design interface is printmaking. We thought about 3D art forms, painting, sculpture, and mixed media, but we kept coming back to intaglio printmaking, which is one of the most technical visual art processes. Here are some examples of aquatint and hard ground etching, just two of the many different techniques printmakers use to create designs on a plate. Each of these plates contributes just one part to the final composition, sometimes just a single color of ink, and as such, the printmaker must think very carefully about how to combine multiple plates to create a complete composition. Each plate is inked and pulled through a printing press with paper to make an impression, and these impressions are layered to make the final edition. Now, the layering process here is actually quite similar to that of 3D computer graphics-based visualization. Each layer of the visualization contributes one piece of visual information, like glyphs, lines, and surfaces. These layers are composited to create the final image. Now, how do we actually build a data visualization design interface using the metaphor of printmaking? We borrow two terms from intaglio printmaking to make the interface work: key plates and impressions. In printmaking, a key plate is the spatial registration for the rest of the print. Each time a plate is pulled through the printing press, an impression is created. In our design interface, key data are the spatial registration for the rest of the visualization and can include points, lines, or forms. A data impression represents a layer of the visualization. Each data impression has at least one key data puzzle piece, as well as variables and visual elements that can be applied as the artist sees fit. Change the variables and visual elements, and you can end up with a drastic change in the visualization. Change the key data, and the design will show up completely somewhere else. The beauty of this puzzle piece-based approach to visualization creation is it avoids the significant cognitive overhead of remembering exactly what each part of the data is, and allows the artist to focus on the visuals and get into the flow. Here we can see key data and data impression metaphors at play. Data impressions are the place where we make the data to visual encodings. Key data and variables can be loaded from other visualization software like ParaView. Visual elements come from the artist's own collection or the Sculpting Viz library. Data puzzle pieces from the left side and visual elements from the right are dragged into the slots in data impressions to make visual changes, then these impressions are composited together in real time to make the final composition. Let me return now to an example of why building this user interface is a hard problem to solve and can't just be a bunch of buttons and toggle switches attached to a data object. Let's say that one day, an artist has created a visualization of some ribbons using a pattern that they sketched in their studio. In computer graphics, we'll usually use a triangle strip to render something like this. Changing these ribbons to some hand-sculpted clay forms is a simple change for the artist. Many artists would consider these lines to be the same visual object, only with different styles applied. However, the computer graphics algorithm used for these clay glyphs is completely different than that of a triangle strip. It's usually implemented using instance rendering. Let's now switch over to a live demonstration of the user interface to see how we encode these computer graphics constraints using metaphor and iconography. Here, we can see the three-part design interface. On the right, we have the design palette. On the left, we have the data palette. And in the center, we have the composition panel where it all comes together into a visualization. Starting in the upper right, we have the plates, which represent the algorithms built by the programmers of the artifact-based rendering engine. Below that are the visual elements that the artist has imported from the Sculpting Viz library or their personal collections. These include color maps, glyphs, lines, and patterns. On the other side, we have key data and variables. Data and visuals are placed into data impressions in the composition panel to make the visualization. Let's walk through making a simple change to this visualization. So far, we have the Gulf of Mexico ocean floor with a color map applied to elevation, and a glyph layer that shows chlorophyll and salinity. The more chlorophyll, the denser the glyphs. So now let's say we wanted to replace the salinity variable with temperature instead. All we need to do is go over to the data palette and drag the temperature scalar variable over into this data impression, and the visualization will update accordingly. We can also double-click on the color map, and it will bring up a color map editor that allows us to create custom color maps based on the data values. Let's now work with a multivariate visualization. Here we have the data impressions for a nearly complete Gulf of Mexico biogeochemistry visualization, including the ocean floor bathymetry and the terrain for context. We also have the ocean current streamlines, and we have some glyphs for chlorophyll. Let's add one more layer, glyphs for nitrates. Before we get started, let's open up a visualization viewer so we can see results of our work as we make changes. The first thing we need to do is drag over a plate list and create a data impression. Now that we've created our data impression, we can drag over some key data. So we have the NO3 nitrate concentration key data. We'll just put that right in the key data slot. So we notice how the visualization updates right away with our key data. So obviously this kind of obscures the entire visualization, so let's go ahead and make those glyphs a little bit smaller. Let's say a value of 0.3. So we made our glyphs a lot smaller. So next, let's take one of our glyphs from the library of artist-curated glyphs here, and drag that over into the glyph slot on our data impression. So notice how the glyph slot is highlighting blue to tell us that this is where we can drop the glyph puzzle piece. Notice also how the icons match. So I can't drag the glyph puzzle piece into the color map slot, I can only drag it into the glyph slot. So now our glyph has updated in the visualization. Next, we're going to apply a variable. So in this case, we'll apply the temperature variable. This also highlights blue in the data impression. That doesn't do anything in the visualization yet because we haven't applied a color map variable, or we haven't applied a color map yet. So let's do that next. Maybe we'll try this blue color map, see what that looks like. Yeah, I don't think that's quite working with this visualization. Let's try something else instead. Yeah, I think that's a little better. I can clearly see some contrast here and some variation in the data right south of Cuba. I can also go in and edit this color map a little bit based on the histogram from the temperature variable. Let's work with another multivariate visualization, this time with 4 water masses in the Antarctic. We have a nearly complete visualization here, including the bathymetry and land ice surfaces, and the water mass volumes represented as glyphs. We've started to build some streamlines showing ocean currents under the Filchner-Ronne ice sheet, and these already have a blue-green color map applied. We want to show the curvature of these currents, how clockwise or anti-clockwise they are. Let's search our data palette for curvature. Okay, so here's curvature, But wait, it doesn't match the color variable slot on our streamlines. That's because curvature is a vector variable, whereas this is expecting a scalar variable. Let's try filtering by scalar variables associated with streamlines. Okay, so now we have eddy direction. That's the one we actually want, and we can see this highlights blue and the puzzle piece matches. So let's apply that. And we can see our visualization updates with the data. Now, I'm noticing as I look at this, I can't really see the streamlines. Let's change up the line texture so that we can see the streamlines a little bit better. I'm going to pick this line texture right here and apply that to our line texture slot. So notice how in this example we were able to move smoothly from applying data to applying visuals. That's one of the most powerful takeaways from this interface because it allows artists working on a visualization to stay in the flow. While we were building the interface, several artists had a chance to try it and provide feedback. One artist, Deborah Stewart Pettingill, works with many forms of traditional media, including printmaking with Shinkole. She works with master printmakers at Wingate Studio to realize her designs. We can see the process from the studio to the pattern and line visual elements, all the way to the final visualizations, which combine her work with elements from the Sculpting Viz library and a biogeochemistry dataset from the Gulf of Mexico. During the sessions where artists tried the interface, one thing became apparent. Small changes in a single part of the visualization can have huge impacts on its clarity. Between these two visualizations, the only change is the color map that's applied to the bathymetry. Every other color map, glyph, and line are the same. In the bottom version, the bright green dominates the visualization even though it's only a small segment of the overall color map, whereas the top one has much better contrast between the foreground glyphs and the background bathymetry. Notice in particular how the gray glyphs disappear into the sea of green at the bottom visualization, whereas they are much clearer on the top one. These types of changes illustrate why artists need a high fidelity of control when creating visualizations. Each artist that worked with the design interface also remarked about how similar the experience was to working in their studio, with the ability to rapidly experiment with many visual combinations. In this talk, we've shown a new way to present data visualization design process that leverages artistic metaphor and language while still retaining the entire power of the underlying computer graphics techniques. As we saw in the examples, the interface emphasizes rapid exploration of design alternatives. By building the interface on top of the artifact-based rendering engine, the result also allows artists to bring color, line, texture, and form from their existing art practices to the world of data-intensive science. Thanks for your attention. Thanks also to the NSF and the E3SM project for funding and data. I'd also like to thank the rest of the Sculpting Viz collective for their valuable interdisciplinary collaboration on this project, and the artists who have taken their time to provide feedback on the design interface.